stop learning, never stop growing, never stop seeking the brightest star, never stop moving from where you are, never stop trying.
We know in practice that these domes are very flat at their crown and suffer great bending moments, and also cracks in the lowest part, especially in the short axis. This is just an introduction of what a shell is. What is it that is important in the geometry of a shell? We have a circumferential direction and meridional direction as shown there. And it's very important to know this because as we prepare to be Washington Accord ready, then you may ask yourself, what would happen if I was sent to site and what I found was this kind of a structure? What would I do? And maybe you are never taught in class, or maybe you've not gone for the advanced classes. So you need to start asking yourself, am I Washington Accord ready? Actually, Washington Accord is the status whereby you are able to be assimilated or absorbed or employable anywhere in the world. In other words, Washington Accord is regulation or certification for the institutions of higher learning to ensure that their graduates are ready to be global citizens. And when looking at what we teach, sometimes you may find you may have missed. So this is just schematic of a shell. So I want us to just remind ourselves what's a shell. Sometimes it may think abstract. Sometimes you may see simulations like this. This is just a simulation of a domed roofed stadium somewhere. That should not scare you. You need to start familiarize yourself. And before long, you know, oops, I've even seen domes, I've seen shell structures. That's a paper dias at the University of Nairobi, Kenya. So we want to go across the globe and see other similar structures. If you go to London, you see the Millennium Dome in London. That's a dome structure, a dome or a shell structure. Let's now cross over in the Arabian world, in the Arabic world, where oil comes from. You find very many structures like those, oil tanks. What about in Rome? We can see the Pantheon in Rome, an ancient building. That's a dome structure. You can see, very fancy indeed, with a lot of architectural features on it. But the bottom line, as a structural engineer, you need to know what's a dome structure. That's the same structure from a different direction. Even St. Peter's Basilica, you know, it's a dome structure, a different type of dome. The geometry is different. Some are circular domes, others are spherical domes, conical domes, and so on. Others are flattened. That's a Kwapak dome in Moscow. We are going across the globe. Remember, we said we want to be Washington Accord compliant. So you had better get used to this. Wow, the US Capitol, okay, the diameter of maximum 29.2 meters. And these are the oil tanks, different designs of oil tanks, and different support systems. It's a high time we got used to this because we need to be global citizens. Grain silos are other types of structures, dome structures, cylindrical dome structures with closed ends. We need to get familiar with that before we run away. Let's go to Iceland. Igloo for Eskimos is also a dome structure. It's a dome structure. What about this in Cameroon or Chad? These are made from earth and grass. They are also dome structures. So you see, they are not strange. We know them. We have those also in Kenya, the Redile homestead in Kenya. Those are also dome structures. So you better get used to knowing them. These are also some Native American tribes live in such dome structures. We know a dome is a very stable structure. And in our next videos and lessons, we shall learn how to design a shell structure. I hope by now you feel very ready to be a global citizen and that you'll not be embarrassed to be employed in a place where you need to design a shell structure.
Never stop learning, never stop growing, never stop seeking the brightest star, never stop moving from where you